Hey, hi, good evening. I'm Sumalya Shah. I'm working as a senior software engineer in Intuit. So I'll be today talking about multi-threading in Java. So I'd like to ask that whether I'm audible and whether you can see my screen. Okay. So I will start teaching regarding multi-threading. So first we need to understand what is multithreading and why multithreading is required in real life examples. So suppose you have a server. Okay. Now if you have a server, then it can handle multiple requests at a time. So suppose you are doing www.google.com. So the Google servers is serving multiple requests at a time. So how it is doing that? So it's basically spawning multiple threads. Now people have confusion between what the difference between threads and processes. So now, if we talk about the threads, so we can think that there can be many threads in a process, and there can be multiple independent processes. So one of the first difference between thread and a process is basically memory. So the threads share the same memory among themselves. So we can think different processes like P1, P2, P3. So now what is a process? So suppose you are opening a file in your system, that's also a process. You are calling an API or you are calling somebody. So that's a process. So one process can have multiple threads. Now now all the threads of this process share the same memory, but different processes share have their own memory. Now, there is also another concept like then if all the threads share the same memory, then what is different between all the threads? So that is basically the memory is also of two kinds. One is a stack memory, another is a heap memory. So when I'm talking about that the threads are sharing the same memory, I'm talking about the heap memory. But every thread has its own stack memory. Because if you don't have a stack, then how your function will execute, right? Now, now how the threads can talk with each other. So we'll see this in how we can synchronize the threads within themselves, and also we can processes can also talk from between themselves. So that is not a part of discussion today. So we'll be discussing threads mostly. So this is basically a one-hour discussion. So I'll be spending like first 5 to 10 minutes in the theory, then we'll be deeping down to the practical and how to create threads in Java. There are multiple points I'll be covering. So now let's go to the theory. So is there any questions or anything? Okay, I was just I'll be checking that whether there is any uh, comment over here. Okay, so you can every 5 minutes I will be checking the comments. If you have any comments or questions, I will be addressing that. So now we'll go and see that how we can create threads in Java. So I think you can see my screen. So here I have written down a pre-written code. So I'll be basically showing you that how you can create the threads. So I think this is yeah, I have zoomed it basically for your benefits so that you can see it. So these are some of the topics that we'll be uh, discussing today. So this will be a very short time. So I'll try my best to cover these things. So how we can create threads in Java? So there are two processes. One is if you create uh, an instance of thread class. Another is if you create a runnable instance. So I will show you both the methods. So first I will show you if I do it with the thread method. So what I will do, I will basically go and create, basically I can show you, okay, so I have already make a demo thread kind of thing. Okay, so okay, so this is a class demo thread. We are implementing the runnable class. So this is the another way of creating the thread, but let's create a fresh class. So for example, demo to thread. So in this class, we'll basically have to extend the super class or the parent class thread. So whenever we'll be extending the super class or the parent class thread, so we should give a run method. That means what is the task that needs to be executed in this thread. So that's why we will write a run method over here. So for example, here I am just writing the thread name and I am doing that. Okay, this thread is running. So this way I can create a thread class extending from the main thread class in Java. Now, how to run this in our main class? I'll also show that. So it's very simple. So basically, you will create, for example, this is my thread. So okay. So I have created a demo2 thread uh, class, right? So what I will do, so I will just, you can name it anything else also. So we'll give new demo2 thread. Okay, that's it. So it's very simple. When I have created, I am creating a class by extending is basically we are using here inheritance. We are extending the thread main thread class in Java, and then I am instantiating it over here. After that, the only thing I will do, I will only do my thread dot start. So I'll also come to the part that there are different. I'll also discuss about the thread lifecycle. So whenever we are doing my thread dot start, it doesn't mean that the uh, thread is starting. It means that the thread is now pushed into a runnable state. I will discuss details for the thread lifecycle. So just now run it and see what is happening. So this is a single thread I have created. Now suppose if you want to create again another thread. So for example, my thread 2. And you also start my thread 2. Now let's see what happens. If I try to run this, then see my thread 1 is also running and it has stopped executing, and thread 0 is also running. So here you can see that thread 1 is running is being printed fast, and thread 0 is printed last. And again if I run it, now see the order has changed. So why this is happening? So these are some of the interesting things I'll be talking to in today's session, because whenever I am doing like my thread dot start, It's not running at the same time. So first, what it does, it basically changes its states to runnable. So I am doing my thread dot start, my thread 2 dot start. Now two threads are now in the runnable state. Now we have a Java runtime internal thread scheduler, which basically decides which thread to start first. So when we ran the program first, at that time, thread 1 was started first, but in the second time, thread 1 started first. Now again, if I run it, see, thread 1 is starting first, thread 0 is first, is being printed last. Now, another thing you can also watch over here, in the uh, last, I have basically written over here system.out print hello world. So you can also ask that why system.out, why hello world is being printed at very fast, where I have already started the threads over here. So this is basically the fun about multi-threading and asynchronous programming. So these statements are getting executed. That doesn't mean that the run method over here has got executed. Okay, so that means that only I have converted the states of these threads to runnable. It's not it running. The thread scheduler will make them running. Now, okay, so we have now first learned that how to make thread using by extending the thread class. Now, another way also we can make threads in Java. That's by implementing the runnable class. So here there is another thread I have made. So here what we are doing, we are creating a class which implements a runnable interface. What is an interface in Java? Interface in Java basically is uh, is a kind of a skeleton which only have the contracts of the methods. You can also say those abstract methods. So runnable interface, if we go to the runnable interface, it says that it has only the contract of run. So if you define a class implementing runnable interface, you have to define a definition of the run method. That means what you want to execute in this thread. So for example, here what I am doing, I am printing the number. So this is also, I will cover this static synchronized void. So ignore these things for now. So here I am printing the numbers from 0 to 9, and I'm also printing the current thread names and also the number. So what's happening is, okay, now if I make a thread use implementing runnable, then how to run it in our main class? We'll see that. So for example, here my thread 2 will now I will replace it by our runnable class. So how to do that? We'll do the same thing. We'll create a thread instance, which we'll create a new instance of thread, and in the constructor argument, we'll give the instance of our runnable class. So what is a runnable class over here? A runnable class is basically our demo thread wala class. Okay. So what I will do? Okay. So for the sake of clarity, let us first create our runnable class. So what is a runnable instance? That is a demo thread. So we make this instance of runnable. Runnable is the interface. Now we supply that instance within the constructor of our thread class. Okay. Now this is the only change if you want to create thread using, I mean, implementing runnable interface. So now you can ask that where which method we should use. So you can use anyone. But the thing is, if you are implementing runnable interface, then you have to define a run method. But whenever you are using uh, the extending thread class method, then you don't need to mandatorily give the run method. Then you can ask that then if I don't give any run method, then from then what will be executed in that thread? So the run method will be inherited from the main thread class. So if you go to this thread class, you can see that there should be a run method. Okay, I can show you that. So I'm not currently finding it out, but yeah, you can check that it's basically the run method will be inherited from the main thread class. Now again, if I try to run this program, let's see what happens. You can see that this was our demo two thread method where we have printed thread is running, and the runnable method, that is demo thread, is basically printing 0 to 9. So here you can see that thread, since the first thread has got started this time first, so it's running like that. But this is not, we are not sure that whether this thread will be started at very fast or not. So now you can also say that if I want to start a thread uh, before another thread starts, so how to do that? So we'll see those methods. There are multiple ways of doing that. If we can do synchronization of threads, we can do joining operation of threads. We can also set the priorities of thread. So suppose if I do the same thing, okay, I will for now will remove these things to show you one thing. Suppose I am now only focusing on this class, the demo thread class. In the main method, I am also changing it to our runnable class. Okay, so what I will do, the same thing, new thread. So here within the new thread, you can also give the run method, the definition of the run method within this predicate. So we'll learn predicate and also single functional interface in some other class. But here also we can give the function definition by this. Suppose here I will write basically that for loop. But anyways, for now, let's stick to what we have written in demo thread. So here I will write new demo thread. So I am doing the same thing. Okay. So there is nothing difference between my thread and my thread 2. I am basically creating different instances of threads, and now I am starting to do that. I am starting the threads. Now let's run it. So here you can see that we have two threads. Two threads are executing simultaneously. So here you can see from thread 0, it prints 0, 1, 2, 3, 4, 5, and then again thread 1 gets started. It's print from 0, 1, 2, 3, 4, 5, 6. Then again from thread 0, 6, 7, 8, 9, 10. The 8, 9 is getting printed. Then again in thread 1, 8 and 9 are getting printed. So you can see it's basically behaving like it's happening concurrently or parallelly. So we'll touch upon what's the difference between concurrency and parallelism. But here you can see a single processor is basically executing multiple threads. So here you can see the thread scheduler first gives some time to execute thread 0. So within that time, it executes this 6 lines. Now the thread scheduler tells that, okay, you have used your time. Now let's context switch to the other thread. So the thread scheduler is doing this funny thing, like this very exciting thing, interesting thing, that it's basically context switching to thread 1. Now thread 1 is doing its job, and then again thread 0 is doing its job. Now you can see, now here I have only created 2 threads. Now if I want to create more threads, then context switching will happen among all the threads. So suppose here, if I create, for example, another thread, okay, then what will happen? You will see a mix of two context switches. Thread 0, thread 2, okay, then thread 1, then thread 0, then again thread 2, then thread 1, thread 0. See? So we will be not sure from outside that which steps will be executed when. Okay. Now, okay, we have been like 22 minutes, so I will check if there are any comments over here. Okay, there's no comment. Okay, so what we'll do now, we'll see that how we can do synchronization between threads. For example, you want that this thread, that is our demo thread, is printing 0 to 9. Now after thread 1 print 0 to 9, only after that thread 2 should print 0 to 9. So how to do that? So there's a concept of synchronization. So synchronization, basically, I will show you what is synchronization. For example, whenever, suppose there is a single object, okay, object 1, and there are multiple threads T1, T2, T3, which are trying to access this resource. What we can do, so I maybe some of you have knowledge about the semaphores, basically a kind of a locking mechanism. When T1 starts working on O1, it basically keeps a lock. Okay, it does the work, and then while it exits, it's unlocked. When T2 comes, it will first check that whether this resource is locked or not. If it sees that it's locked, then it will wait. Whenever it will see that it's unlocked, then it will try to acquire the lock the same way T1 does. And then when it does its works, it will again unlock it. So T3 will also work in the similar way. So in Java, there's a concept of monitor. Every class, every object or class, object is basically an instance of class. So every class or object has its own monitor. So suppose this is one class, you can see monitor as a this. So in case of synchronization, one thread first tries to acquire the lock of its monitor. Then it can work on that object or class. So to make it simple, Java has one keyword synchronized. So we can have synchronized methods. We can have synchronized object, synchronized blocks. So we will try to cover them later. But let's see an example how the synchronized keyword works. For example, here, if I give the keyword synchronized, then just a minute. Uh, okay, so we can basically define some methods as synchronized. So here, for example, if I give the word synchronized, okay, it's giving some error, so we'll try to uh, give some things over here. Hmm. So what you are trying to do, like here you can see that it's printing 0 to 9 in a very random fashion. We'll try to do it in a mannerly fashion. So if thread 1 starts first, then thread 1 should first print 0 to 9. And if then thread 2 starts, then thread 2 should print 0 to 9. So that is our aim. Okay. So what we can do is, okay, not done this. We just check once. Just a minute, I'm getting a call. Okay, sorry for the interruption. We are back. So if we make an method synchronized, then if one thread is accessing this method, then another thread will basically not able to come to this method. So here we have to make this a static synchronization. So I will cover that later. Why we need to make it static. So static means that this synchronization is respect to the class demo thread. It's not respect to an object. Okay. So now if we go to our main method, here you can see that we have created multiple instances of demo thread, and using those different instances, we have created different threads. So as over here we have seen that if we if one thread starts first and accepts that lock, then the other thread have to wait for it until and unless this thread gets unlocked, right? So that's the okay. Now we'll see in practical how this is happening. So if I now run the main method, you can see for some reason thread 0 has got the opportunity to start first by the thread scheduler. So it's basically printing 0 to 9 in a sequential manner. Then thread 0 has, but here thread 0 has started. But that doesn't mean that thread 2 and thread 3 hasn't started. It has already started, but it's basically in the waiting state. So here is another state of the thread. So first state of thread is basically it's inactive. Now it's basically runnable when I do dot start method. When the scheduler basically tries to schedule the thread, then it's basically runnable. And from runnable, the thread can also comes to either terminated, that means it's exited as done its operations, or it can go on to blocked or waiting state. So here you can see that thread 0 and thread 1 and thread 2, all the three have started. But thread 0, since is working on the same method. What is the method over here? The method is print numbers. Okay. That's why the other threads are not getting the opportunity. So whenever thread 0 starts, ends executing, it unlocks the monitor of the class. Then thread 2 somehow got opportunity to acquire that lock. So it's basically a kind of race condition. The three threads trying to acquire the lock simultaneously. So what may be the consequences of these race conditions? So there's another mm, phenomena, that is deadlock. So we'll try to cover that also when deadlock occurs. So here you can see that this way you can try to synchronize synchronize the threads. Now there is another method also for synchronizing the classes or the threads. No, sorry, the threads, not the classes, is basically the join method. For example, first we were trying to we have one problem, like you can see that hello world is getting printed at the top from the main method. But now if I want that after all the three threads have completed its execution, only after that we want to print hello world. How to do that? So there we can join the threads. So what we will do over here? So in the main method, this is basically the main thread. So I can do my thread dot join. What does that mean? It means that my current thread will halt its operation until and unless my thread completes its execution. Okay, let's run and see what happens. So here you can see my thread is basically the thread number is 0. Okay, so 0 has completed its operation from 0, thread 01 to thread 09, and then hello world has been printed. But now you can say that why thread 2 has got printed? Because here the context switching is happening between the threads. Okay, because the main thread is also a part of the thread scheduler class. I mean the thread scheduler object in the Java runtime. So whenever the context switch is happening, when the main thread gets the opportunity, it sees that okay, my thread has already completed its operation, so I will start my operation. So after this, what is the operation of the main thread is basically creating a system out.println a hello world statement. Okay. Now, if you want to print the hello world at the bottom of the stack trace, I mean the print trace, what you will do? Very simple. Then you need to tell that, okay, I will also halt my execution. So the main thread is telling that I will halt my execution until and unless my thread 2 stops executing. I mean, finishes execution. Let's see what happens over here. See, thread 0 has completed, thread 2 has completed, thread 1 has completed. Only after thread 2 has completed, hello world has been printed. Sorry, only after thread 1, uh, thread 2 has completed, hello world has been printed. So, suppose if I change it to thread 1, then you will see, okay, yeah. Now, if I change it to thread 3, then see, after thread 3 corresponds to thread 2 over here. After thread 2 has completed, then hello world has been printed. Now, if I want that after all the threads has completed, hello world should be printed. So what I should do? I should again add a line. I should do thread 2 dot join. That means the main thread is waiting for the three threads. My thread 2, my thread 3. If I do this, then I will see that hello world is getting printed at last. And this will happen every time. This is guaranteed. Okay, so these are the two ways how we can synchronize between the threads. One is basically using synchronize keyword, another is using join method. There is also other methods like wait and notify, using which we can also synchronize the threads. We'll see some examples of that also. So before that, I will check if there is any question or comments. Okay, and there's no questions as of now. So let's go and see. Okay, so if anybody wants to get this code, I can share this code, and also you can. Also, how you should practice this? Basically, you should also run the debugger. Now, what I will do, I will show I will spend basically very 1 minute or 2 minutes to how to see this in a debugger, how these things are happening. Okay. Uh, let me give here one debugger. Okay. And every time I will check that what's the thread that is working on so that I can show you that how the context switching happens in the runtime. I will also uh, create, do these things in the debugger. Okay. Let's debug now. Okay. So see, I am creating a thread. That's fine. I have created a thread. Okay, I have started the new thread. Okay, I have started thread 2. I have started thread 3. I have done these statements. You can see my still now my thread haven't yet started. Okay, so this is the fun of asynchronous programming. Now you can see system.out.println is coming. Okay, for some reason we didn't get the breakpoints in this over here. So we'll see why the breakpoint didn't come. We'll again do it. See, now this has come to this run method. Okay, so within this run method, so I can check that this is the demo thread, and over here I can also check that what's the current thread over here. So the current thread is 0. Okay. Now if again if I go and see that this is getting stuck in this method only. all the other threads are not coming over here. We are still in thread 0. Okay, sorry. We have come to thread 1 over here. For some reason, that thread has got already displayed. So you can also keep your console over here. See, we have basically started thread 1. Is basically what has happened over here. When it comes to print numbers now, thread 0 tries to acquire the lock. But when I have uh, basically paused in the debugger, thread 1 has acquired the lock. That's why thread 1 is basically now executing this 9 lines. Okay, now we'll see what's the thread. Uh, yeah, now we can see this is, yeah, thread 2 has now come, has been able to acquire the lock. So you will see that thread 0 has started first, so thread 0 come over here, but it was not able to acquire the lock because I basically intentionally paused the debugger over there. Okay, so here you can see that thread 2 is getting printed. Okay, now you can see, yeah, now thread 0 has come. So you will again see that thread 0 hasn't gone to print number because it has already come to this position of the line. Line number, uh, this is line number, if I, yeah, this is line number 14. Thread 0 was waiting at line number 14. So this is very interesting. Thread 0 was waiting as line number 14. That's why it was, it directly came from here, thread 0. So you can see, okay, now thread 0 has already started, have finished this. Now this main thread have got the opportunity to run from thread scheduler, luckily. Okay, now after that, hello world has been printed. So this way you can debug. So the more you debug, more you play with this multi-threading close, multi-threading things, your concepts will be more clear. So we have like 15 to 20 minutes remaining. So I will be covering two most interesting things. So for the synchronization things, you can learn more about non-static synchronization and the uh, object synchronization and block synchronization and method synchronization, obviously. Uh, okay. Uh, Now let's let's learn about two things, that is wait and notify method. Okay, so I'll remove these lines for now. So I have done basically one. Okay, for example, I want to create two threads. So suppose there is a bank. Okay, I in the bank is basically an object, you can say. Within the bank there is some balance, and we can deposit some money to the bank, and we can withdraw some money from the bank. Okay, now suppose I want to write an application that if I want to deposit, if I want to withdraw some money from the bank, then I shouldn't have negative balance. If there is some negative balance or non-positive balance, basically, then we should wait until and unless some money gets deposited into the bank. For example, this is our use case. How we can do that? So if you simply thought that, you can think that we will write a function which will basically doing a poll kind of method. We'll be polling, we'll be writing a while loop, we'll be polling that whether the bank balance is not non-zero, is positive, then we will only execute withdraw method. But that's very I mean, your main thread will be basically blocking for that. So if we want to do that kind of scenario, how we can do that? So there are two keywords in multithreading in Java: wait and notify. So whenever, okay, I will show you that over here what we are trying to do. For example, there is a single object. Okay. Now T1 is coming. T1 comes. It basically sees that some of the conditions are not matching within the object. So in our use case, basically balance is not satisfying. So we'll make this T1 to waiting state. Okay. Now when T2 is coming, suppose T2 will deposit some money to this bank for object. Okay. It deposits that money. And then I can basically issue a notification from there. So there are two methods, notify and notify all. I will be coming to that part. But first try to see that we can notify. So a thread can notify an object. So what does notify does? Notify basically notifies the threads that went to waiting state due to this object. So due to this object, which thread went to waiting state? T1. So this basically notifies T1 that, okay, you should now come to your active or running state. You should now become active. Okay. So this is the thing that we'll be trying to demo today. So remember one thing, whenever we'll be using wait and notify, we have to wait on an object and we have to notify on an object. It's not on threads, it's on an object. And whenever we'll be trying to wait on an object, we have to first get its lock or monitor. So I was talking about the synchronization concept, right? So first we have to get a lock on this object. So first step is get a lock on the object. The second step is to create, to basically make the thread wait on that object. If you are not giving a lock, getting a lock on that object, you can't do wait on that object. You can't do. If you try to do it, you will not get any compile time error, but you will obviously get runtime error. Okay. So we'll see very quickly this in the demo. Okay. So there are two. So threads means basically we have already learned how to make threads in Java. So there are two threads. One is deposit thread. One is withdraw thread. So deposit thread will deposit money, and withdraw thread will try to withdraw the money from your bank account. Okay. So here, what I have written, that this is a withdraw function that is getting called from the run method. This is very simple. So over here, I have written a synchronized block on bank object. Now you will be able to answer that why you will need synchronized over here. So what did I tell over here? That first you need to get a lock. So every synchronized block or method or static synchronization will not get executed until and unless you acquire a lock on that object or class or method or block, anything. Okay. So here That's why this block will only gets executed when we'll be able to acquire a lock on the bank object. So bank object is basically a private variable over here of type bank. I've already shown you the bank class. Okay. So here what we are trying to do, suppose we are trying to withdraw some X amount. Now we are seeing that whether that amount is greater than the balance of the bank. So we don't want a negative balance in the bank. So suppose if someone has 100 rupees, he should not be able to uh, withdraw 200 rupees. Okay. So that's why this check is over here. This while loop, simple while loop. So here we have just written one statement waiting for withdraw. Whenever we will see that our bank balance is less than the amount we want to withdraw, then we will just wait on the bank object. Okay. Whenever we'll be using wait method, we have to because wait can throw is basically checkable exception, checked exception. It can throw checked exception. That's why we need to surround it with a try catch block. Okay. Now you can see this will get. I will basically create debug points over here to show the demo. It will wait until and unless it gets a notification from any other thread on this bank object. So this thread will wait for infinite amount of time until and unless it gets a notification. After it gets a notification, then only it will be able to withdraw the money. Okay. So it's basically, so this is basically the withdraw thread. Okay. Now, now you can see that, okay, when the bank wait is, suppose I want to withdraw 100 rupees. My bank balance is 0. Someone deposits 10 rupees. Then also 10 is less than 100, right? So what will happen when bank dot wait will get execute, and when the thread will again come to the active state, because someone deposits 10 rupees and it also notifies, then it will again go to this while loop and it will again check when the whether the bank balance is less than the amount that we want to withdraw. So it will again basically evaluate it to true. So it will while loop will again get continued, and again the thread will go to waiting state. So it's basically it will oscillate like it goes to wait state and then again comes to active state. Then again says that okay, my bank balance is not sufficient. Again it will go to waiting state. Okay. I'm just helping to understand. I'm trying to understand that how, trying to explain how it happens. We'll show the demo right now. Now, after when we see that our bank balance is greater than the amount we want to withdraw, then we'll basically print withdrawing, and we'll just do bank dot withdraw amount. Okay. Now we'll see the deposit thread. Deposit thread is pretty simple. So for the deposit also, you need to first get a lock on the bank object. Now you need to see that when my withdraw thread is basically going to the waiting state, that means it has already unlocked the object. That's why my deposit thread will be able to acquire this object, bank. So it will basically deposit the amount and it will notify. Whenever it will notify it, the control will come from over here. Okay. We'll show this in a minute. Another thing is, I just want to mention that what's the difference between notify and notify all. Notify will, suppose there are multiple threads. I have here there is a single withdraw thread. Suppose there are multiple withdraw threads. Then if I do notify all, then it will notify all the threads, and all the threads will try to come out from the waiting state to active state. But if I do notify, then it will randomly pick one thread and notify that thread, and it will come out from the waiting to active state. Okay, so let's run it. Okay, so this was our bank example. So I have written this code so that I can save some time, basically. Okay, cool. Now see what happened. So I will here also do all the debuggers over here. So how much time is left? Okay, 4 to 5 minutes. Okay, I will try to finish this. Okay. Now see, we are making the bank object. We are making the withdraw thread, and we are withdrawing how much amount? 100 bucks. Now we will be depositing 50 bucks in two installments. Okay. Now I have created three threads, and three threads. I am also doing a thread slip. See here, it's coming. It see that okay, my amount is withdraw thread has already started. It's seeing that okay, my thread, my amount is less. My bank balance is less. So it goes to waiting state. Okay. Again, it sees okay, my bank balance is less because I have already only deposited 50 bucks, right? Now I have to again go to wait. Now it's telling me that is false because I have deposited 100 bucks now. So now it's withdraws it. Okay. So here, if you see the uh, sequence of the print statement, so it's basically waiting for withdraw, waiting for withdraw. So after two attempts, it's basically withdrawing. Okay. So in the deposit thread, I haven't given the pointers, or basically haven't given these things notify so that you can see that how it switches the context. I will try to run it again to see how it switches the context. So quick things. Yeah, it tries to see, okay, balance is insufficient. It goes to wait state. Okay. Now the deposit thread has started. I deposited one amount. I notify it. Then it goes again to the withdraw thread because now the withdraw thread has come from blocked or waiting state to the active state. It again says, okay, my bank balance is not enough. It again goes to waiting state. Then again deposit thread becomes active. Deposit thread is basically like, I mean, depository is always active. This is the second deposit thread. So you will see from the main function, I have created two deposit threads, one for 50, another also for 50 rupees. Now I again notify it. Then it checks, okay, now my bank balance is 100. So I will go and withdraw the money. So this way, wait and notify works. Okay. So I think last 2 minutes are remaining. I will, okay, anything I misses, I will check over here. Okay, so one thing, some theory things I would like to tell you that we are not able to cover, like thread life cycle we covered, creation of threads we covered. Parallel and concurrency is basically whenever there is a context switching by a single processor to execute multiple threads, then it's a concurrency. If the processors are uh, not doing context switching and all the processes or maybe the threads, not the threads, all the processes are occurring independently, then it's a parallel processing. There's also a concept of thread group is basically you can group some threads into a thread group and you can create a parent of it. You can create child of a thread group or maybe a child thread group of a parent thread group, and also you can make grandchild and you can go up to nth child. Uh, then we discussed about thread synchronization, thread lifecycle we discussed. So we didn't discuss about executor service. So executor service is very good topic. Is basically suppose you don't want to spawn too many threads. You have only capacity of creating 10 threads, for example, and you have, for example, 100 jobs. So you can create an executor service of thread of 10 threads, and you can give 100 jobs as an array of runnable tasks, so that the executor service will pick up those jobs randomly and use only those fixed number of threads to execute those tasks. So what's the benefit over here? Is basically you don't need to create so many threads, or also the threads you have to create only once, and those basically is a thread pool. So the pool of threads, the threads in the pool is basically will be reused again and again. So that is the concept of executor service. So for the sake of time, we're not able to discuss today, but we'll discuss that later sometime. So this is the basics of multi-threading. So if you like my teaching, please share and subscribe and like. Thank you.